All right, so for number 12, it says, at what speed would a 2,400, could somebody get that real quick? 2,400 kilogram satellite orbit, if it were 1,400 kilometers above the Earth's surface, assume the Earth has a mass of 6 times, um, that's interesting, 1,024 kilograms and a radius of 1,600 kilometers. All right, so let's go through. I already drew the picture. Um, the speed they want is going to be the tangential speed, right? That's the linear speed. So it's going to be going perpendicular to the radius. So let's change that too. So pretend this is the center of the Earth. And so the distance from here to here was given to us by saying that the radius of the Earth is 6,400 kilometers. And then also that extends, we'll do like orange. So from here to here, to the satellite, that is 1,400 kilometers above Earth. And so if we add that up, that gives us our combined radius of 0 plus 0 is 0. This would be 7,800 kilometers. So that's our radius. Whoops. What the heck did I do there? All right. Get my face out of the way there. And so they want to know the tangential velocity, right? And then what was the other thing? They gave us the mass, which is interesting, right? So the mass of the Earth. Did they give us the mass of the satellite? Yes. I'm sorry, this is written funny. It's actually 10 to the 24. I was trying to figure out why so the mass of the Earth is actually 10 to the 24. That's how it should look on your screen. It's just when I copied and pasted it. All right. So that's the mass of the Earth. So let's pick a different color. How about purple? So the mass of the Earth is 6.0 times 10 to the 24 kilograms. And so there's a mathematical relationship, and then this is based on, so I don't know if I want to derive the whole thing, but remember, I'll just kind of I'll feed you some breadcrumbs. Remember that force is equal to the mass times the acceleration, okay? And then centripetal acceleration can be associated with the velocity over r, right? But also, in other words, force is equal to the mass times the velocity over r. But also, gravitational force can be equal to the mass of the capital letter G, which is the gravitational constant. Oh, shoot, what am I doing in this video? Okay, there we go. Oh, I did it again. I'm hitting the wrong back button. Okay, there we go. But this is equal to the gravitational constant, capital G, times m over m divided by r squared. And so one of these is the mass of the Earth. Well, anyways, if you do a bunch of algebra, you get the relationship that V is equal to the square root of, keep making mistakes here, the gravitational constant G times the mass of the Earth, right? No, say Earth, divided by the radius. Okay? And also remember for this radius that kilometers, you have to multiply this by 1,000, right? So 7,800 kilometers, that has to be converted to meters, right? So that would be multiplied by 1,000, or we just add 3 zeros. So we'd say 78, 0, 0, and then we add 1, 2, 3, which is 7.8 times 10 to the, so from here, 1, 2, 3, 4, 5, 6 meters. Okay? And the gravitational constant G is just, and you should have this in your notes, is equal to 6.67 times 10 to the negative 11. Okay? And give you guys a second to process that. Okay. So we just basically, to find that velocity v, we've got to plug these numbers in. So I'm going to say my velocity v is equal to the square root of 6.67 times 10 to the negative 11 times the mass of the Earth, which is 6.0 approximately, 6.0 times 10 to the 24. Divided by the radius, which is 7.8 times 10 to the 6th. Okay. And so then the final answer would be, it's about 7160 meters per second. Let me That should be it.